Welcome to your future. Welcome to Vision Academy. Let us unlock your full potential.
We have all stared at a massive algebra question on an SSC, banking, or board exam and felt a sudden wave of panic. When you are facing a swirling storm of brackets, fractions, and floating numbers, it can be difficult to find a starting point. To solve these, we need a systematic approach. Today, we are going to assemble a 10-rule toolkit. These rules provide the logic needed to break down multi-step problems into a series of manageable operations. Grab a pen and let's get started. Look at this equation. The blue number at the bottom is the base. The red number floating at the top is the index, or exponent. It simply tells us how many times to multiply the base by itself. So 2 to the power of 3 expands to 2 times 2 times 2, which gives us 8. This relationship between the base and the index is the logic that drives every single rule in the toolkit we are about to build. We will start with two foundational tools. First, the index 1 rule. Any number raised to the power of 1 is just itself. 9 to the power of 1 is 9. 100 to the power of 1 is 100. Second is the zero index rule. If you see any non-zero number raised to the power of 0, the answer is always 1. 5, 100, or even -7 to the power of 0. They all turn into 1. These rules are useful because they require zero calculation. When spotting a 1 or a 0 in an index, you can simplify that part of the equation immediately and move to the next step. Now let's look at multiplication. When you are multiplying two terms that share the exact same base, you simply add the powers. Here, we have 2 to the power of 3 times 2 to the power of 4. We keep the base, add 3 and 4, and the result is 2 to the power of 7. Division works using the same logic, but in reverse. When the bases match, you subtract the powers. For 3 to the power of 7 divided by 3 to the power of 4, you subtract 4 from 7, which results in 3 to the power of 3. During these operations, the base number never changes, and it never multiplies itself. The only numbers changing are the floating indexes. Recognizing matching bases is a shortcut. It allows you to process multiplication and division by using simple addition and subtraction instead. Next, we have exponents separated by brackets. If a power is stacked outside a bracket, it multiplies with the power inside. 2 cubed squared means the inner 3 and the outer 2 multiply together to become a 6. It is important not to add these stacked powers together. Addition is only for when you are multiplying two separate matching bases. When a power is applied directly to another power, you multiply them. If there are multiple bases inside the bracket, the product power rule applies. The outer exponent distributes to every base inside. In this example, the squared power duplicates and applies to both the 2 and the 3. We use the same distribution for fractions. The quotient power rule shows that the outer power applies to both the numerator and the denominator. 2/3 squared becomes 2 squared over 3 squared. Brackets serve as a distribution requirement. If there is an exponent outside a bracket, it must be applied to every term inside. Negative powers can be counterintuitive because they do not result in a negative number. Instead, they result in a fraction. You can think of the negative sign as a prompt to flip the base. The negative symbol detaches, stretches into a fraction bar, and moves the base to the denominator. Then we have fractional indexes. A fractional power represents a root. 16 to the power of 1/2 is the same as the square root of 16. The denominator of the fraction identifies which root you need to find. For more complex fractions, like 8 to the power of 2/3, both a root and a power are involved. The bottom 3 becomes the cube root index, and the top 2 remains a standard power. Negative signs and fractions often make an equation look more intimidating than it is. Once you recognize that these are simply prompts to flip the base or find a root, you can rewrite the problem in a format that is much easier to solve. This is your 10-row quick revision table. You can take a screenshot or finish your notes now to keep these formulas together. Let's see how these rules simplify a multi-step exam equation. By identifying the specific rule that applies to each cluster, the matching bases, the negative powers, and the brackets, we can simplify the problem step by step until we reach the final answer. When you have these 10 rows committed to memory, you have a clear path forward for any algebra or simplification problem you encounter. If you found this toolkit helpful for your exam prep, Please like, share, and subscribe to Vision Academy. We will see you in the next lesson.
Like this video? Subscribe to our channel. Share this video. Thank you. Shukriya.